Good morning, everyone. This is Shiva from Soundbox Irrigation Design Services. Welcome everyone for the third session of irrigation design. I'm just going to continue from the yesterday session. Yesterday, for the past two sessions, we have discussed about plot, plan, and design, and how to determine the system capacity, selecting the sprinklers, and then sprinkler layout. So, today I'm going to discuss about the rest of the things such as dividing into zone, sizing, and laying out pipe. Okay. So, so before getting into that, I just want to keep you uh, aware about the two things which we need to keep in mind when we are designing irrigation system. So, before starting into that, let me discuss about those two factors which we need to consider whenever we are designing the irrigation system. So, first one is what are the heads we can connect in a single zone that we should be able to aware about this. For example, sprays have operates at the 330 psi, rotors operates at 45 psi, rotary head operates at 45 psi. So we need to make a zone according to the operating pressure. For example, so both sprays and rotors cannot operate in a single zone because they both have different operating pressure. So it is not uh, possible to connect both these sprays and rotors in a single zone, but we can connect both rotors and rotary heads in a single zone because they both have same operating pressures. Similarly, we cannot connect bubblers with any of the above sprays or rotary heads, but we can connect rippling emitters dippings in a single zone, so because they all have similar operating pressure, so we can connect this in a single zone. So we have to connect this propellers in a separate zone. We have to connect this spray in a separate zone. We have to connect rotors and rotary head in a separate zone. So yesterday we have discussed about the sprinkler selection and their layout. So we need to connect them according to the maximum flow and then pressure available. So and one more thing is pipe layout. That is, so what is in the sense, for example, this is pipe layout. We this factor also we need to keep in mind. In the 3 by 4 inch pipe, we can only maximum pass 10 GPM of uh, 10 GPM because if you pass more than that, then the velocity in the line in the pipeline will be more than 5 feet per second. So otherwise, if the velocity is more than 5 feet per second, then the friction loss will be very higher. So automatically the pressure will be very low in the pressure available will be very low in the heads. So we need to keep that in mind. How much water can be passed in a, particular size of pipe? In 1 inch pipe, we can pass 16 GPM. In 1 by 4 inch pipe, so 26 GPM. Similarly, for schedule 40 class, we can pass up to this level. So these things we need to keep that in mind whenever we are sizing the pipe. So this is actually software is doing this automatically because we have input put the data previously we have put the data in the software. So we know how much velocity we need to allow in the each pipe. For example, we are just allowing only 5 feet per second because that is a standard for uh, every pipe in the irrigation industry. So keep that in mind. So let's get into the uh, dividing into zones. Okay, so I'm just going to show you design the yesterday's design. I'm just going to show you how we have separated into different zones. For example, if you see this is a valve here, and this is for rotors because rotors and drip zones have different zones because for how to say that they both have different valves. For example, drip zones has different valves assembly. Bubblers and spray rotors has different valve assembly. So this is the symbol for valves for sprinklers, bubbler, and rotors. So first we just connect a valve to particular zone. One, two, three, four, five, six. Because we have connected only rotors in this zone. As I have discussed earlier, we can only connect a rotor or rotary head in a single zone. We cannot connect sprays in the along with these rotors. And then one more thing is uh, we cannot connect more than 25 psi, 25 flow GPM. That's why we have currently only connected only 1 2 3 4 5 6 rotors only, because the restrictions is only 22 GPM, so we cannot connect more than that. And in the next zone we just connected two rotors in a single zone. And in this one we have connected 5 5 6, we have connected 5 rotors in another zone. So this we need to keep that in mind, that we have connected uh, rotors in a single zone, and we just separated these rotors in a three different zones, because according to the flow availability, if we have more flow, then we can connect these two zones in a single zone. So we don't need to separate it to two zones, because we our flow availability is very limited, so we need to keep that into separate zone. And yeah, next one is, we just connected the flow, we just connected the rotors in a different zones. And this is also for rotors, which has 19.5 GPM, this zone has 19.5 GPM. So we just see, look at here, we have MP rotator, we have rotary heads attached to here. So as I said earlier, we can have rotors and rotary heads in the same zone. So because they both have 45 psi operating pressure, so we can connect that in a single zone. That's why we have connected this into a single zone. So we just everything connect to this one. And next one is, this is also rotor, we connected this rotor in a connected these rotors in a different zone. 1 2 3 4 5 6 7, we connected 1 2 3 these 7 rotors in a single different zone. And similarly, this is the symbol for drip zone assembly. As I said earlier, sprinklers and drip has different types of zone assembly, valve assembly. So this zone one number has 9.95 GPM flow requirement. So we just connected this area of drip into this area drip into this zone. And this is simple. Similarly, uh, we have connected this bubblers in a separate zone. So look at here. So this is bubbler one, and then this line is going to from this area to this area, and then it goes to this area. So we can see this we have connected a buffer into different zone. Similarly, uh, here we have we have connected in different zone. So we all connected this bubbler in this zone to this zone. So this we need to keep that, because bubblers cannot operate along with either spray or rotors, because it has only operating pressure of 20 psi. So we need to connect it in a separate zone. And one more thing is, this zone we have connected this, we have used this zone for the rotors. So we need to connect rotors and our rotary heads in a separate zone. So as I said, you see here we have connected rotary heads and rotors in a separate zone. And one more thing is, this we have used drip assembly for this area. So we have used 14.4 GPM drip assembly here. And okay, and one more thing is, we have used this zone for drip assembly in this area. Next one is this 10th one. We used this for spray. This is which is operates in 30 psi. So we have to connect the spray in a different zone. So we connected this whole sprays in this zone. Similarly, we have connected this whole spray into this zone. Likewise, we have connected this whole zone in this zone, and whole sprays into this zone, and this whole sprays into this zone. So keep that in mind whenever we are designing this irrigation design. We have to separate. We have to make zoning is the very important factor for every irrigation professional. And for these drip zones, we have connected to a different drip valve assembly. So hope we have understand how to dividing into zones. And one more thing is, as a sizing out of pipes. So as we discussed, as I show you, I showed you the criteria for sizing and layout. This is for 3 by 4 inch. We can only pass up to 10 GPM. Otherwise, the flow GPM, the velocity will be higher than 5 feet per second. So we need to keep that in mind. So let's take this zone. So we have used here one and of one quarter inch of pipe. We have used 1/4 inch of pipe here because why? Because this zone requires 18.2 GPM totally, right? So 18.2 GPM, we have to pause this 18.2 GPM in this line. So which is the safe size for 18.2 GPM? If you look at this picture I have showed previously, we can only pause up to 16 GPM in 1 inch. But 18.2 GPM can be paused in one quarter inch. So that we have used 1.5 inches here. So it's very easy to understand. Similarly, as we passed this to the, we have separated the flow into two sides. Like we have passed to this is 35. We are just only passing. We're just only passing one zone here. So see, if you see here that we are just only passing only one rotor, which requires which not requires more than 10 GPM. So we are just used 3/4 inch of pipe size here because we are just passing for one rotors in this side. But if you look at this above side, we are just use 1 inch pipe because we have to supply uh, one, two, three, four rotors, so which is more than 10 GPM. So that's why we have used 1 inch pipe here. But we have paused. So after converting this, after covering this to this, we need to pause three zones. So we just automatically be reducing the size according to the flow needed for these three zones. Because these three rotors requires less than 10 GPM. So we are just reducing the pipeline. So this is how to we need to laying out the pipes. So we need to consider we need to keep that in mind our as well. And at the same time, uh, we need to use for example, let's say, yeah, this one. We need to use sleeves in the hard areas, like if there is any roads or pathways or anything, if the pipeline has passed under this, we need to use sleeves over the pipes because it is susceptible to the pressure from the upside down. So we need to cover this with the one more safety sleeve. So that's why we have used sleeves in the every pipes. So this also we need to consider this in our design. And one more thing is approximate location of controller that we need to uh, keep that in mind because it should be either easily accessible to the residential owner. Otherwise, if it is away from the home, then it is very difficult to operate because in the rainy conditions it's very difficult to operate. So we need to keep that close to the owner as much as possible. And hope you have understand something about this laying out and different languages. So this is how we are just making design. So watch my previous two sessions so that you can easily understand from beginning. So don't start this from this third session because you need to start from this, then only you can able to uh, continuing the session concept. So I'm just finalizing this plan. So this is how we make we just first we made uh, we just determined the plot area, and then we just determined system capacity, and then we just selected the sprinklers, and then we just laid out the sprinklers according to the distance, and then we just divided that rotors into different zones or sprinklers into different zones, and then we have just laid lay we just sized the pipes according to the flow, and then we are just submitting the whole design to the client. And we are making a budget analysis how much it will approximately how much it will cost for the homeowner to implement this project. So everything we are done in from the Soundbox Irrigation Design Services. So if you have any doubts regarding this services or anything, you can always contact us. Just Google us about our company. So thank you for joining today. Due to the lack of time, I cannot able to make a video more than 15 minutes. So as of now, bye bye. If you can just kindly ask me.